In this video, you will learn how to find the number of permutations of n objects taken r at a time. You will also learn how to find the number of permutations when there is repetition. So what is a permutation? A permutation is the arrangement of objects in a certain order, order being the key word there. When you are doing a permutation, order is important. If the order didn't matter, we would do something we call a combination that you will learn about in the next video. Let's take a look at example 1. Let's say there are 10 math problems on a quiz. In how many orders could those 10 problems be written? Well, if we think about our basic counting principle from yesterday, I have 10 problems, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And when I start to write the quiz, I still have those 10 problems to choose from. Once I've written the first problem, though, I only have 9 left for the second. Then I only have 8, and so on. To find the number of orders I can write these 10 problems on a quiz, I need to multiply the number of possibilities I had when I was writing each question. If I multiply these out, I'm going to get 3,628,800 different ways. But now let's say I had 10 different cards in a hat, but I only wanted to select 2 of those cards. Well, I only have 2 spots. When I select the first card, I'm choosing from 10 different ones. But since I've now selected one of those 10, when I take the second card, I only have 9 cards left to choose from. This would multiply to 90 different ways. The 2 examples that we've just done are both examples of permutations. Example 1 is a permutation of n objects. Another way to calculate the permutation of n objects is by doing n factorial. What a factorial is taking a number and multiplying it times the number 1 less than it until you get down to a value of 1. On your calculator, you could enter that number, then go to your math key, scroll over to PRB, which stands for probability, and the fourth option is a factorial. If you then press enter, you will get the value of 10 times 9 times 8 times 7, 6 times 5 times 4, 3, 2 times 1 without having to individually calculate each one. Example 2 was an example of a permutation of n objects taken r at a time. What this means is that we only took 10 objects, but only 2 of them. This is written, again, with n being the number of objects and r being the number you're taking. If we wanted to calculate example 2 without doing our basic counting principle of 10 times 9, I would need to follow the permutation formula for n objects taken r at a time. Let's think back to what we were doing. Originally, we were taking 10 objects. So that would have been 10 times 9, 8, etc. But then we decided that we only wanted to use 2. So we wanted to get rid of the 3rd, 4th, 5th, etc. cards that we didn't use. To get rid of them, we basically wanted to divide. When I divide, that cancels all of those that were left in the factorial that we didn't use. The way that you can calculate that then is take n factorial and divide by n minus r factorial, meaning take the number of objects factorial and divide by your number of objects minus how many you're actually using. If you notice here, in this numerator, I had a 10 factorial. In the denominator, I had a 10 minus the 2 we used, which gave me 8 factorial. And so that left us with just the 10 times the 9 had I done my basic counting principle. Let's now take a moment and learn how to calculate these permutations by hand. In example A, I have 5 objects and I only want to use 3 of them. Again, I could do the basic counting principle, 5 times 4 times 3, and that's going to give me 60. I can also think of it as n factorial, 5 factorial, divided by 5 minus 3 factorial. This would be 5 factorial over 2 factorial, which, remember, the factorial means 5 times 4 times 3 times 2 times 1, and the 2 factorial means 2 times 1. So again, you can see you're just doing 5 times 4 times 3. Now, your calculator will also calculate this. Let's take n first, so 5, and then again go to our math key, and again scroll over to the probability, and you'll notice your second option says NPR, standing for the number of objects, permutations, taken R at a time. Go ahead, press enter, and then enter your value for R, the number of objects you're actually using. And then if you press enter again, it'll calculate the number of permutations for you. So on B, we could just do 4, the math key, scroll over to probability. Second option is NPR, taken 1 at a time, and get a value of 4. By hand, that would have meant 4 factorial divided by 4 minus 1 factorial, which gives me a 4 factorial over 3 factorial, which means I've got 4 times 3 times 2 times 1 divided by 3 times 2 times 1, and this is why we got a value of only 4. If you think about your basic counting principle, if you have 4 objects and you're only going to use one of them, you have 4 different ways you could choose that one object. Please now pause the video and calculate C. By using either the basic counting principle, permutations of NPR by hand, or your calculator, you should have gotten 6,720. Let's now look at the next example. In example 4, you are burning a demo CD for your band. Your band has 12 songs stored in your computer. However, you want to put only 4 songs on the demo CD. In how many orders can you burn 4 of those 12 songs? Well, because I know that order is important, that tells me I want to do a permutation. Then I want to look at how many total songs I have and how many you want to use. Remember that NPR, N is the total number of songs, P is for permutation, so order was important, and R is the number you're actually going to use, so 4 of them. Again, I can just calculate this on my calculator. 12, math, scroll over to probability. Option 2 is NPR, R is 4, and it looks like there would be 11,880 different orders that I could burn 4 of 12 songs. Now you could have also done this with your basic counting principle. Again, if there was 4 songs I wanted to burn, when I choose the first song, I still have 12 songs I can burn. When I burn the second song, I'm not going to want to use the one that we just burned, so I only have 11 to choose from. Then when I burn the third, I only have 10 to choose from. And the fourth, I only have 9 to choose from. If you were to multiply 12 times 11 times 10 times 9, you'll also get that 11,880. Again, you can do this either way. Let's now look at example 5. How many different ways could 5 posters be displayed on a wall? Now this is a permutation of all 5 objects, and it's how many different ways. So the order is going to be important in how I put those 5 posters on the wall. That tells me that this is 5 factorial, n factorial. And 5 factorial means 5 times 4 times 3 times 2 times 1, for a total of 120. You could have also thought of this as I have 5 objects and I want to use all 5. If you calculated 5 NPR 5, you'll also get our 120. In 5B, now we're only going to take those 5 posters and hang up 3 of them. So I can't just do n factorial. I have 5 posters, I'm only using 3. Calculating 5 NPR 3, I get 60 different ways to hang only 3 of the 5 posters. Please now read example 6 and 7, pause the video, and when you are done, check your answers. In example 6, you were trying to make a 5-digit number with 5 different numbers, 7, 2, 1, 3, and 8. Since you were using all 5 of the numbers, you could have just done 5 factorial or 5 objects permutated 5 at a time. That gives you 120. In example 7, you are selecting a president and a vice president from 16 students. So you had 16 students, you were using 2 of them, so 16 permutated 2 ways is 240. Let's now look at the next example. In example 8, we want to know how many letter combinations with Z-U-R-I-C-H can be made if the second letter must be a U. Now remember, you can still use the basic counting principle here if you'd like. And I personally think that when you are trying to do different permutations with restrictions or specific things, it is easier to use the basic counting principle. And so if the second letter has to be a U, remember, I'm going to have 6 letters total that I'm using, but if that second letter has to be a U, I only have one option for that second letter. At this point then, I've used one of the 6 letters. So when I go to use my first letter, I only have 5 to choose from. Then 4, 3, 2, 1. This means when I multiply them, I really am just doing 5 factorial, which gives us 120 different ways to arrange it, with the second letter being a U. Now another way that you can think of that if you want to use the permutations is you can think about you have 6 letters, but one of them already has a spot. What do you do with the other 5? 5 factorial. Let's now look at B. The last letter can be a C or an H. So again, I have 6 letters. This one can be C or H. So I have 2 options for the last letter. But remember, you really only used one of those, C or H. So when you go back to fill in the first, you only have 5, then 4, 3, 2, 1. Here, as far as a permutation, it was still 5 letters that I didn't know where they were going to go. But now I had 2 options for that last one. So 120 times 2, this would either multiply or 5 factorial times 2 to 240 different ways. Please now pause the video and do C on your own. For C, again, the first and last letter could not be a vowel, which in the word Zurich is just I and U. So when I'm placing the first letter, that cannot be an I or a U, so I had 4 letters to choose from. When I place the last letter, since I've already used one of the non-vowels, there was only 3 non-vowel letters left. Then I had 4 letters left to place, 3, 2, and 1. So as a permutation, that was 4 factorial times 4 times 3, which is 288. What you should notice is that each time I have always done the restriction first. It is important to do the restriction first because that tells you how many other letters you have left with that one restriction. Let's now look at permutations with repetition. Let's think about the name Bob. If we have repeating letters such as the B's in the word Bob, you can come across repeating letter combinations. Let's now write the different combinations we could have with the word Bob. If B1 is first, then either I'm going to have O and then B2, or B2 then O. If O's first, then I could have B1, B2, or B2, B1. If B2 was first, I could have O, B1, or I could have B1, O. If you take a look at the permutations that we've listed and cross out the ones that spell the same quote-unquote word as another one, you're going to have fewer permutations because really in the word Bob, B is B, not B1 and B2. So looking up here, I've got B-O-B, but then down here I also have B-O-B. Then I have B-B-O, but again down here I have B-B-O. Also here I have O-B-B and O-B-B. So there was 3 repeating words. So if you have some objects that are the same, you have to use the following rule. The number of permutations of n objects in which P and Q are alike. Here's what we mean by that. In example 9, we want to know how many 7-letter patterns could be made from the word cupcake. In the numerator, n represents, remember, the total number of objects. And so this word cupcake has 7 letters. In the denominator, the P factorial and the Q factorial were the repeats. The letter C appears twice in the word cupcake. It repeats. And so we have 2 of a letter repeating. And so really, the number of different 7-letter patterns that you could have with one of those letters repeating once would be 7 factorial divided by the repeats, 2 factorial. And that divides to 2,520. So the denominator is the repeats. So let's look at example 10. The first thing I would do is figure out how many letters are there. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I have 11 factorial divided by. Now I need to go through and figure out how many different repeats I have. This is where I put different markings under the like letters. So these X's represent all of my I's. I had 4 I's. But there was also 4 S's and 2 P's. So we have to divide by each of those repeating letters. So now if you calculate this out, keep in mind you probably are going to have parentheses around your denominator. So I've got to do 11, math, probability, factorial, number 4, divided by parenthesis 4, factorial, 4, factorial, 2, factorial. And this calculates out to 34,650. Please now pause the video and complete examples 11 and 12. In example 11, we had 12 letters total, and the letter S appeared twice, the letter M appeared twice, and the letter O appeared twice. So I had to divide by 2 factorial for each of those letters. That gave me 59,875,200. In example 12, we had 7 letters total, and the letter T appeared 3 times. So I had to divide out the letter T repeats. That divided to 840. Please now complete tonight's assignment.